So hi, my name is Curt Micol. I'm an infrastructure engineer at Simple. And today I want to talk about incident management and introduce everyone the incident complexity framework. So first of all, let's talk a little bit about incident response in general. So many ask, what is incident response? This is really a set of procedures for dealing with some type of disruption. And I add to this piece the confidence in its resolution. Incident response typically starts with these questions. What is wrong? What is impacted? How do we escalate or how do we communicate to a wider audience? And then probably the most important that we want to constantly ask right during the incident is the issue resolved? Because it's really important to, once you have a problem, solve it and get out of it so you can go back to your work. So with that definition in place, let's look at a couple models, and these are entirely my definition. They're not like studied or anything, but these are just what I've experienced in my years of doing ops work. So the first type of incident response that most people are familiar with, I think, is what I call the ping ops model. Basically, someone finds something broken, asks, what do we do? And then someone responds, ping ops. I mean, by the laughter, I suspect everybody's familiar with this model of incident response. So it works, right? I mean, we've all done this, but it puts the onus on one team. It doesn't scale very well unless you hire lots of ops people when you grow your company. And then it's generally engineering focused, right? That puts the incidents just in the infrastructure, just in the engineering org. And that's oftentimes really insufficient for support to do their job when they experience an incident, or let's say marketing, for example. So the other type that I've encountered, I actually helped develop. I worked at Heroku in 2012, and an engineer by the name of Blake Gentry and I started talking about this, and we formed a working group. And we built an incident response system based loosely on the incident command system, the National Incident Command System. And it's like what national parks use, FEMA, Department of Homeland Security. So I call this the product state model. And basically, here's kind of a state chart. I don't think they use this anymore, but this is what we kind of developed at the time. And we established 4 states of the platform. Everything's healthy is the green column there. Potential incident is the yellow. Identified incident is orange. And the major is red. And these corresponded with our status site at the time. The blue boxes you see there are metrics that we use to trigger through the state machine to find out where we were and which level we should move through. We used a lot of simulations. I think we did 17 simulations with lots of engineers to really iterate on this and figure out what would work. And it was a pretty big success. There was some concern earlier over the burden that it would add, but once we finished training, most people got into it and really dug the response and the confidence they had. And if you want, that picture on the right there is a picture of the blog post. They wrote a blog post about a year ago. It's a really cool blog post. Check it out. So now I want to talk with a little story here. So I joined Simple in July last year, and we utilized the ping ops model. The ops team primarily, people sent us, there's a disruption, and we handled it or whatever. But in August, we were set to replace our transaction processor, which is a very core piece of our infrastructure. This is where card swipes go through. And this was a very complex change that required lots of coordination with partners, many different teams inside Simple. And obviously, ping ops isn't sufficient when you require 7 hours of downtime on your service. Everybody's kind of waiting for something to happen. Ops team cannot be the only one to handle this. So I kind of built this small incident command system around this for dealing with it. And we learned a lot about incident response during this. So here's primarily what we learned, right? We had zero confidence in the system because it was new. Most people were not trained on it. Our response was almost solely focused on the engineering side of the organization. With this size of a change in your infrastructure, it affects the customers greatly. And so engineering is not the only one that works with customers, right? They primarily just work with the back-end services. So this affects support, this affects marketing, and we found that to be really lacking. So, our communication during the incident wasn't great either. Again, engineering focused, so our timelines and our updates really only hit a small audience inside the company. And we didn't have really any way of answering those important questions that I covered. We knew what our timeline was, but if anything wavered off that, there was a lot of confusion. So none of these were really surprising, right? We knew going in, like we needed something, but we weren't well trained on it, and we needed something better. So we knew we wanted a communication system and a coordination system that spanned across the company to handle large disruptions like this. And there's nothing like this that I know of. So I began looking at the product state model, because that's what I had experience with, right? I helped build this at Heroku. It worked really well. I started talking to some people at Simple, and a lot of people got behind it. I did a couple talks at some of our company meetings, and everybody was like, yes, let's try this. Except it failed miserably, actually. And the reason being is that we had this really small incident one day. Check disruption. So when you use your Simple card or whatever, if you take a picture of your check, that picture hits a team, that team reviews it, make sure all the numbers are clear and all these details they look for, and send it to a partner. Well, we had a communication outage between our partner and us. And I ran this little incident, and it took like an hour to resolve, so it was really minor. It wasn't no real-time impact for customers. But I took this little incident and ran it through a product state and realized it would be impossible to do this in a state machine. So it turns out that the product state model depends on the complexity of your product. And it really begins to break down as your product has more and more facets. Oops, think I went too far? Yeah, sorry. So looking at that state diagram earlier, here's all of our different features we have. Our customers interact with us in many different ways. We have many, many different features. We have ACH file transfers, our activity transaction service. I mean, there's a lot of moving parts to Simple. And financial industry, if anybody's familiar, is a cluster of things. I mean, it is madness how money moves across our systems. So it's just simply not maintainable. On the other perspective, we have many moving pieces each day. Every day we get ACH files, we get these transfers, direct deposits, and these only affect a subset of customers. So metrics like 25% of customers impacted mean nothing to us, because maybe 1,000 customers have transactions that day, or deposits that day. But for them, it's critical. If they don't get their paycheck that day, this is their livelihood. They can't pay the bills, and there's a cascading failure for them. So we also have to define communication methods for each of these. Like I said, I mean, we're only a portion of these people are affected, so we have to communicate with those individuals. We have 160,000 customers. We we just spam all of them with a problem that only faces 1% of them. And then even if we could define all of these, what would that look like? Could anybody here imagine the amount of metrics and state and triggers we would need to determine to make our way through that bowl of spaghetti? It would be terrible. So the more facets you have to your product, the less definition there is. And so looking back at the check deposit issue, we needed something that we can't define every way that can fail, or any of these features. So how do we determine the severity of these features? And then also, again, like I mentioned, there is no real-time impact, which is another dimension to an incident. If there's a real-time impact, obviously you work in a different way. So we started over. What do we need, right? We're a bank. We want security, risk. We want our systems to be usable by our customers. We want them to use us, obviously. We want them to put their money with us, right? So we need to be good. So I started listing what I wanted. So we knew that we didn't want any system to be engineering focused. We have a lot of people that are not engineers at Simple, and they have very important concerns of how the customer works with their money. And then we knew that any system must not be a burden on those responsible. That's one thing I learned at Heroku, is that if we add an incident response system, it can't be a burden because no one's going to use it, which then you have no incident response. And then we want every system to be usable in many cases across every team. We want integration, which is non-engineering focused but knows all the bank logic. We want them to use a system like this. And then we want to increase confidence in response, because we don't know what failures we're going to hit. We know that we did the processor conversion. That was a feature we built, but we don't know what we're going to face. And customers rely on us to be available. And then we wanted a procedure that built up a team. We couldn't hire people that sat around all day waiting for incidents. We knew that the team had to be built up around each one. So I began researching the ICS system, Incident Command System. There's a lot of documentation out there of how it works. And I came across this PDF. This is just a screenshot of it. But it's this incident complexity. And this was fascinating for me. And this was like a light bulb moment. What this thing does is that there's a type 1 here, and there's 5 types. Type 1 for them is the most severe. And basically this lists out in a general bulleted list the responsibilities of personnel responding to incidents. And this is at the national level, right? We're talking like 9/11 would be a type 1 national response. But, so this is a new perspective, right? We now are looking at the incident and the complexity of it and how we want to respond to it, rather than trying to determine the ways it could fail so that we knew how to respond. So then we could base our response on that impact and that complexity of that incident. So I went through and researched, we use GitHub for all of our ops incidents, or like ops on-call alerts or whatever. And I went back and looked and kind of boiled down to these 4 questions. Every incident can be fit into these. How many teams are impacted? That's important because you want to know how many people you need to bring on board. What's impacting external and internal customers? Internal customers here would be like support, marketing, who are using data systems and customer systems to interact with customers. And then there's our partners. We have a lot of partners. But we realized we were missing something. What exactly is an incident? We know that process conversion was an incident, and that's a planned feature. So we want to cover unplanned and planned. And so we needed a definition that encapsulated these types of events. So this is what we came up with. Any disruption to normal business activity. This seems vague at first, but what this does, and it very powerfully does this, it doesn't require us to define methods of failure, and it also avoids defining those methods of failures for teams. It doesn't define their work or how they do their job. They just know that here's what we're supposed to be doing on every day, and this is a disruption. That makes it really powerful for every team to use this. So we took this, and out of all of these definitions and these questions we're asking, we created this framework, and this I call the complexity model of incident response. Basically, this is what it looks like here. This table, this is just a markdown table I took a screenshot of, but we have 5 levels of complexity, and you can see this matrix here that's the 4 questions we ask. And each one of these levels then determine our response. So none of these are specific to simple either. Like we've designed this in a very general way because we felt if we designed it for simple, it'd be a snowflake, then we were probably going to fall into either designing for engineering or just for marketing. We want it to be very general. And then, so from all this, our incident management strategy started to come together. So like I said, we have 5 levels. Level 1 is the least impactful, and level 5 the most impactful. And if those of you who know DEF CON defense readiness conditions, this is flipped from that, because an interesting aspect of this complexity model is that your normal business day is level 0, 0 added complexity to your day, which is where everybody wants to be. Everybody just wants to do their job and go home. And I thought it would be a lot easier to communicate to people that weren't familiar with DEF CON or those other types of things. So while developing this, I also found 3 properties for incident complexity. And these are kind of fascinating in some ways. So the first one is incident complexity can never decrease. So if we establish a level 4 incident, which is a real-time impact to customers, we can never say that that is a level 3 again, because at level 4 we define responsibilities that must be accomplished and the expectation we have of that response. And if we were to decrease, some of those responsibilities would fall to the side, which would mean that we wouldn't actually accomplish those. Like level 4 has a lot of post-incident remediation, right? We have post-mortems that are ran, we want issues created, we want to know how to fix it so we don't run into this again. If we decrease to a level 3, we don't get those. Incident complexities all require an owner. So as soon as the complexity is established, an incident commander is assigned. That's the owner. It might be the person responding, it might be the one resolving the incident on the lower level ones, but this person is in charge of seeing it all the way through and then following it up with the post-incident procedures and maybe facilitating the post-mortem or finding people to do that. And then the third one, which was interesting, I didn't discover till late, was complexities are globally recognized. A level 4 engineering incident actually impacts our customers, so that impacts every single team. It's simple. Maybe marketing, for example, doesn't have much stake in the communication around that, but they can't define it differently. It's a level 4. It affects our customers. It's globally recognized. So I mentioned the incident command organization, and each level builds up these things. And this is based off the incident command system. We use only 3. I think they do 5. I think is the amount of teams. So we have the command organization, the communications organization, and the operations. The incident commander, as I mentioned, is the owner of the incident. They're entirely responsible for everything around it. And all communication about the incident comes from them as well. They are the funnel and decision maker for that entire incident, that short-lived incident. And then we have a communications org we build up. And this is a vital role. We call it incident signaler because every time I chose a name for this role, somebody would get hired and have that title, which then, it was a mess. So if anybody at Simple gets the title incident signaler, they are doing incident response or nothing else. So they're gonna change, because I'm so tired of changing this title. But, so they're responsible for formulating the communication of the incident, not about the incident, but of the incident. So like, the status site would be one where we want a consistent message with what support is telling customers, right? We don't want different people telling different things. All communication from the incident comes through incident signaler, and this can branch, as you can see there, and each one of these roles can branch. And then operations is the engineering side, or the people are gonna fix it. So this one, I mean, we actually don't recognize this very often because a lot of times it's not even infrastructure related, it's business ops or whatever. So, but this can also fork. We have integration, front end, infrastructure, and stuff like that. So how does it work? It actually works incredibly well. We've been doing this since December. It's improved awareness across the company. Customer service representatives sitting on the phones every day know what is happening to the platform behind them. They're generally not surprised when customers call them, we hope. Sometimes they're our first responders, right? But it improved the confidence in our response. We've trained up a lot of people. But first, let's look at a couple of incidents. I want to talk about what an incident might look like, and I talked about this check failure. So here's kind of a list of how we would utilize this framework. And I don't read slides, so you can kind of see all the details there. But we work on getting the data into this team so the team can respond. And that's very important because they generally are trained on what the response is, have the confidence to resolve it. And in this case, like the IC and IE could be the same person. You know, this is a kind of a smaller incident for us. But like something larger, more impactful, like ACH memo files, which is how banks transfer money between each other in a terrible way. Man, if I told you guys what it is messed up. So sometimes, you know, a health check will fire, CR might get a call from a customer who sees it like a second before, but we build up a whole incident response. This almost always has an incident signaler. We almost always go to status about this because people are definitely affected. And then we generally have a postmortem. Actually, I think we're pretty consistent, unless it's the same problem over and over again and it's out of our control. But we usually have a postmortem where the whole team gets together and talks about what happened, what we learned, what we didn't know. So what needs work? Obviously, we're humans. We didn't build a perfect system. It's getting there, though. We're getting really good at this. We need a better bat signal. That's one thing we're working on. What I mean by that, if that isn't an obvious analogy, is we need something to turn on this team a lot faster. Right now, it kind of trickles in a little bit. I mean, sometimes it'll be, you know, alerting systems. Other times, customer. We have a couple morning customer relations people that are very, very often spotted in the ops channel to come and ask us if there's any failures we see. So we need a better bat signal for it. We need more education. We need more teams using it. We definitely have not done that. And we need better documentation. Now, we've just recently actually built up a part-time team around this to improve education. It's now a part of new employees coming into customer relations. It's part of onboarding for new employees, engineering. We're working on training and continual training for it. We're also training in some level the actual incident responders and the people that would fill this role. So like we have the integration team is all trained as level 4 incident commanders. Me and Michael Gorsuch are probably the only level 5 because we're the only ones willing to try to figure out what that means because level 5 is a tough time. But so since December, we've had 156 identified incidents, which sounds like a lot. Now, this includes everything from, okay, Jenkins isn't running jobs, so ops opens up an incident, and it might be a level 1 or level 2, and they just go and, you know, kick an instance or whatever. Level 2 and level 4 are most common, and we've had 3 level 5s, which are 2 feature releases and 1 unplanned. The unplanned one is a very long story and a very long day. The rule that it added to our complexity framework was that you cannot be assigned to a role more than 4 hours. because I ran this level 5 incident. I did it for, I think, 6.5 hours, and I was very, very tired at the end. And then we had 1 week in April where we identified 11 incidents, and the last one's my favorite. One of those level 4s, we had 8 teams involved in our incident response. And this is a major real-time impact issue, right? To have 8 teams working together in a coordinated, well-communicated way was awesome. The other cool fact about that is we had 0 engineers in that incident, which really accomplishes our goal of not making it engineering only. So a question came up. I gave this talk to a couple people in preparation because I don't talk to a lot of people and I want to make sure I wasn't an idiot. And a lot of people ask, how do we start using this? How would we develop this? And again, we made this very generic. This isn't simple focus. This isn't even revolutionary, right? We've seen a PDF of governments, using this. So what do you need to do? Go back through some of your incidents. Go look at what an outage means to you. Figure out what the impact was. How did you respond? What do you want to see happen? Think in Fantasyland. Think about sci-fi future, what you want to see for an incident response. Go to your harshest one, go to your easiest one, and see what the commonalities are. Find that matrix for your company. And then generalize that impact. You want to make sure that you're not focusing on a single team. We're all a lot here, and watching James ask everybody where they work, and there's a lot of sysadmin and ops, and seem to be a lot of technical folk here. But most companies are not just technical folk. We found marketing and customer relations and biz ops and the banking side do not work the same way engineers work at all. Even just using GitHub internally is a stretch in some cases because they don't know what does this mean? What am I doing here? So we want, you got to expose that. The most important part though is make it so that when someone responds and uses your incident complexity framework, that it's not a burden. You can't have 55 things or whatever you want them to do before they even start attacking the issue, right? Our base level response is create an issue, assign a complexity, you may be wrong, but we'll start there. And then just start dumping data into the GitHub issue. Our GitHub issues are super important for it because they're like our log of the event. That's our first response. That's what we want to do. From there, we can start making determination and decisions based on that data. We do large, I started this trend and some people got a little upset with me, but I paste large sections of IRC chat into this issue. But we found that it's better to summarize at the top of what that all is. I wanted to paste it because I want to remove bias. But we need to have summary there so that people can scan through it and don't have to read. If anybody uses GitHub, you know that your screen doesn't go beyond this width. So when you have IRC chat, you're scrolling sideways, which is a terrible experience in GitHub. Thank you, Kyle Neath. I know that you're the one who fought for that. So I would love expanding. Yeah. Anyways, so you just iterate, right? Just iterate. Find what works for your team. Make it simple to use, and you should have something that builds a lot of confidence. So Simple's incident management system has really empowered the entire company. One of my favorite moments is during that level 5 I was explaining was our CEO, Josh, I can't think of his last name right now, but CEO Josh was in a channel, sorry, I can't remember his last name, was in a channel explaining that this means all hands on deck. He knew what was happening. He had been exposed to it. That's really exciting to see other people getting involved. It's not just ops guys with pagers, pissed off at 4 a.m. It's everybody getting involved and working on it. And it's really built up a lot of confidence in our employees and the work we do. And that means my timer's done. It's been 30 minutes. So thank you. Any questions I can't answer, but go to the Slack. I will respond. I'm also possibly going to be on Hangouts sometime soon to talk about this more, just because I assume lots of people have questions. But we're also hiring as well. Everybody is. So cool. Thank you very much.